Andre Gsponer was a Swiss physicist who spent the 1980s and 90s working on particle physics at CERN. In 1998, he founded the Independent Scientific Research Institute in Geneva to publish technical, open-source engineering assessments of nuclear weapons. This timeline charts Gsponer's taxonomy of nuclear development, moving from pure fission bombs to thermonuclear devices to tailored radiation weapons. At the center of these legacy designs is a shared requirement. They all need a fission chain reaction to function. This shared dependency reveals the exact technological assumption our modern international arms control network is built upon. The 1996 Comprehensive Nuclear Test Ban Treaty states in Article 1 that it prohibits all nuclear explosions. But the treaty's text doesn't actually define what a nuclear explosion is. This map shows the international monitoring network set up to enforce the treaty. It relies on 4 specific metrics: seismic footprints, radionuclide release, hydroacoustics, and infrasound. Every one of these sensors is calibrated to catch the specific signatures produced by splitting atoms. During the treaty's drafting, the United States maintained a specific negotiating position, and the Clinton administration backed it up with ruling letters to the Department of Energy. Those letters established that hydrodynamic experiments remain permissible as long as they stay below the threshold of a self-sustaining fission reaction. Gsponer identified a legal corridor here. Since the entire sensor network and international law focus strictly on detecting a fission chain reaction, they don't cover any weapon that skips that step entirely. That brings us to the 4th generation of nuclear weapons. These are pure fusion devices that throw out the fission primary and operate with sub-kiloton yields. Left is a standard fission blast. Right is pure fusion. Removing the fission primary eliminates radioactive fallout and fast neutron release. Pure fusion operates in fractions of a microsecond, dissipating too quickly to couple with the ground, erasing the seismic footprint. Gsponer mapped out the engineering pathways to reach non-fission ignition. The first is inertial confinement fusion, which uses converging energy pulses to compress and heat a tiny fuel pellet until it ignites. We saw a civilian breakthrough in this exact process at the Lawrence Livermore National Laboratory in December 2022. Their national ignition facility finally crossed the threshold for net energy gain. They pumped in 2.05 megajoules of laser energy and got 3.15 megajoules out. Civilian scientists proved net energy gain works. Weaponizing that reaction allows a nation to bypass every verification layer of the test ban treaty. A second option is magnetized target fusion. This method implodes a pre-magnetized plasma, letting the fuel reach ignition conditions at much lower compression ratios. Then there's the antimatter catalyzed microfission pathway. A few nanograms of antiprotons striking a subcritical core can spark ignition in a surrounding fusion layer. It requires no critical mass and no standard weapons-grade materials. The physics are mathematically sound, and civilian projects regularly hit these milestones. But we have to be clear. Any claim that a 4th-generation weapon is currently fielded remains informed speculation. Whether these weapons sit in an arsenal today or not, the engineering blueprints prove a structural blind spot exists in global surveillance. The implications get even stranger when you look at Proton-Boron 11 fusion. It's an aneutronic reaction, which alters the energy output of the detonation. Because this reaction produces its energy as charged alpha particles instead of fast neutrons, there's no blinding neutron flash. Look at this sensor interface. Early warning satellites look for the classic double-hump ultraviolet curve of a fission event. With a pure fusion thermal release, that specific flash doesn't happen. To a Cold War surveillance network calibrated for fission signatures, an advanced 4th-generation detonation looks like a compact thermal anomaly. In 2014, U.S. officials told the press early warning satellites recorded no explosion or breakup event along the flight path of MH370. But the Defense Support Program's infrared sensors are only designed to eliminate traditional fission-driven detonations. They're not tuned to catch exotic plasma events. Forbes argues the monitoring gap means the government's no detonation statement doesn't rule out a 4th-generation fusion event along MH370's flight path.